Let's do a few examples of graphing. This here is an exponential function whose base is 2. So that means y equals 2 to the power x is the parent function. Let's come up with a table using the x values -1, 0, and 1. So 2 to the power -1 is a half, 2 to the power 0 is 1, and 2 to the power 1 is 2. This has a horizontal asymptote of y equals 0. This has some transformations. This -3 is inside the function. So this has gone right 3. This +1 is outside the function. So this has gone up 1. So now let's make a transformation. So the right 3 means we're going to add 3 to the x values. The up 1 means we're going to add 1 to the y values. So the new table is going to be 2, 3, and 4. The new y table is going to be 3/2, 2, and 3. The new horizontal asymptote has been shifted up by 1. We only use the up and down because the horizontal asymptote is a function of y, is y equals. So we'll graph our horizontal asymptote at y equals 1. And then we'll plot our points. 2, 3/2, which is 1.5, 3, 2, and 4, 3. So our function is going to get infinitely close to our asymptote and go up. This is increasing from left to right, which makes sense because our base is bigger than 1. So this is growth. Now let's graph this logarithm. The base of this log is 3. So the parent function is y equals log base 3 of x. So our table, now since this is a logarithm, we've switched x and y. So what we normally use as x values for our exponential functions, we will use as y values for our logarithm. To find the x values, I will evaluate the base to the power of y. So 3 to the power -1 is 1/3. 3 to the power 0 is 1, and 3 to the power 1 is 3. Logarithms have a vertical asymptote of x equals 0. Now let's look at these transformations. This negative out front tells me that this has been reflected over the x-axis. This -2 is on the outside. This tells me this has been shifted down 2. Okay, so let's construct our new table by making a transformation. This negative affects the y values. So I'm going to multiply the y values by -1. The down 2 also impacts the y values, so I'm going to subtract 2 from the y values. Since I haven't changed any of the x values, those are going to remain the same. Now for the y values, I'm going to multiply by -1 and then subtract 2. This is going to be -1. This is going to be -2. And this is -3. Since none of our transformations had an effect on the x values, our vertical asymptote is still x equals 0. We'll start by plotting our vertical asymptote, which is x equals 0. And now we'll plot our points. 1/3 -1, 1 -2, and 3 -3. So our function is going to get infinitely close to our asymptote, and then it's going to flatten out. Here we have an exponential function. The base of our exponential is 3. So our parent function is y equals 3 to the power x. So our table is going to have the values -1, 0, and 1, and we'll evaluate 3 to the power x. So this will be 1/3, 1, and 3. This is an exponential, so it has a horizontal asymptote of y equals 0. Okay, what are the transformations? This -1 means we've reflected over the x-axis. This +2 means we've gone up 2. So let's take a look at how this affects our graph. This -1 is going to have an impact on the y values. So we'll multiply by -1. This +2 is also going to have an impact on the y values. So we'll add 2. So again, none of the x values have changed. Our y values will multiply by -1 and add 2. 1/3 times -1 plus 2 is 5/3. 1 times -1 is -1, plus 2 is 1. And 3 times -1 is -3, plus 2 is -1. Our horizontal asymptote has been affected by both of these transformations. So we'll shift it up 2, and so our new horizontal asymptote is y equals 2. So let's go ahead and graph it. Our horizontal asymptote is the line y equals 2. And we'll go ahead and plot our points. -1, 5/3. Well, that's just less than 2. 0, 1 is here. And 1, -1 is down here. So we're going to get infinitely close to our horizontal asymptote. And then we're going to come down. It looks like this because recall that we've reflected it over the x-axis. Okay, this one's a log. Recall that this is a natural log, so the base is e. And since it's a log, our parent function is going to be log base e of x. So our y values then will be -1, 0, and 1. To get the x values, we're going to raise the base of our log to the power of y. So e to the power -1, e to the power -1 is 0.4 approximately. E to the power 0 is 1, and e to the power 1 is 2.7. Recall that e is about 2.71828. Since this is a log, it has a vertical asymptote of x equals 0. Now let's take a look at our transformations. This has a transformation. This has been vertically stretched by a factor of 2. This minus 2 is on the inside. So that means we've gone right 2. And this minus 5 is on the outside, which means we've gone down 5. So let's look at our new table. This vertical stretch of 2 means that we are going to multiply the y values by 2. This translation of right 2 means that we are going to add 2 to the x values. And the down 5 means that we are going to subtract 5 from the y values. So we'll go ahead and add 2 to the x values. And we'll take the y values, multiply by 2, and subtract 5. So negative 1 times 2 is negative 2, minus 5 is negative 7. 0 times 2 is 0, minus 5 is negative 5. And 1 times 2 is 2, minus 5 is negative 3. This vertical asymptote only has the plus 2 that affects it. So we'll add 2 to the vertical asymptote. So we'll go ahead and plot our vertical asymptote at x equals 2. Now we'll plot our points. 2.4, negative 7 is down here. 3, negative 5 is here. And 4.7, negative 3 is about down here. So we get infinitely close to this asymptote, and then we kind of flatten out. So here we've done a few extra examples. Thank you for watching.